Hello everybody, welcome back to another video. Hopefully you guys are all having a wonderful day. Today's upload is going to be an El Nino update. I'm talking about the ENSO outlook, potential for a El Nino Madoka, and the potentials for just an El Nino in general. So I haven't done these in quite a while. This video, I think last time I made it was sometime in August. So I think it was high time to make this, especially since they just recently updated this. However, before we get into this video, if you like this channel, if you'd like to support my work, consider subscribing to my channel, consider liking the video. You may be wondering why to do so. You know, if you're just, if you're a new subscriber, or no, if you're a new viewer, this is your first video you're ever watching, roam around the page, roam around my YouTube channel, and then consider subscribing. I mean, it's a win-win for me and you. You get the notifications when I post a video, and I get support from you guys. Also, if you are a old returning member, haven't subscribed yet, again, just letting you know the subscribe button is there for a reason. You could subscribe if you want to. So, first off, let's talk about the ENSO. So, at this point, let's go to a summary right here. ENSO neutral conditions are present. Equatorial sea surface temperatures, or SSTs, that's what I will be referring to them in this video, are near to above average across most of the Pacific Ocean. There's a 60% chance of an El Nino in the northern hemisphere for all 2018, and then increasing to around 70% chance of an El Nino during the winter 2018-2019. However, there's a huge and massive catch to this. I said this in so many of my previous videos, and I base a lot of my forecasts and outlooks and all these videos that I make based off the ENSO and the El Nino and what type of El Nino will happen. Because notice how they just said there is a 60% chance of an El Nino in the northern hemisphere. El Nino, they are not specifying what type of an El Nino. So this could be a weak El Nino, this could be a moderate El Nino, this could be a strong El Nino. At this point, we are mostly confident this will be a weak El Nino, and there's a different even whole category, or I should say like species of El Ninos that are called El Nino Madokas that could be weak, moderate, and strong themselves, which obviously have their own impacts differ. So, you can see we have an El Nino Watch, and there's a lot to digest in this. So, in this, this is a slide. The link is basically just type in ENSO Outlook or ENSO Outlook, and you should be directed to this page. So, you can see these are showing the SST anomalies. I'm fairly sure, yeah, this is around the Equatorial Pacific. That is not the best chart. I won't go through every single image on this slide due to the fact that this is a very long presentation, and it will take me about 20 to 30 minutes explaining each. I just want to get down to a 15-minute video, if not less. So, what's an interesting thing is these regions, these Nino regions, and these Nino regions correspond to obviously each different piece of land. There's a Nino 1+2, Nino 3, Nino 3.4, and Nino 4. So, and this just shows you the latest weekly SST, which remember stands for sea surface temperatures. Departures or anomalies are Nino 4, which is this one in the yellow. It has increased significantly in terms of temperatures. Nino 3.4, which is this little black region, so it has a little bit of that yellow region into it and parts of the red into it. So Nino 3.4 is just slightly got warmer above average, around 0.3 Celsius. Nino 3, which is right in here, has 0.1 raised itself by 0.1, so very minimal. And then Nino 1+2, this little black box right here, has dropped in temperatures in 0.4 Celsius degrees, which is shown by this graph right here. So very interesting. And you may be wondering, well, what does this even mean? What does this even show you? Well, an El Nino is basically, let me quickly search this up. I was supposed to do this quick earlier. El Nino, just let's do pattern. So a typical El Nino pattern, just an El Nino pattern, looks something like this. You could see warm and dry across the north, or this is what they lead to. And again, an El Nino is whether the waters are above or below average at a given place in the Equatorial Pacific, which I was just showing you the regions. And then you could see an El Nino also means wet and cool across the south. So if you're a snow lover for the north, El Nino doesn't really mean the best conditions for you. However, again, there are several variations. There's a catch to this. So let's go down. And actually, first I want to show you why these regions matter. So An El Nino Madoka looks something like this. This is an El Nino Madoka pattern as to compare to a El Nino pattern. So an El Nino pattern looks something like this. A typical, just regular old El Nino, weak, strong, or moderate, doesn't matter. Obviously, this one would be a strong one since the temperatures are way above average. This is a strong El Nino. You can see it's eastern based in the Pacific Ocean. The warm waters are eastern based, not central based. And people are asking me if there's a western based El Nino. As far as I'm concerned, as far as my many years of studying, I am fairly sure there's not a such thing as a western based El Nino. And you can see that there are some differences. This is an El Nino Madoka. And what we are noticing with these regions that I was just showing you, 1 and 2 are cooling off. So that would correspond to, to this area right here. So it is cooling off, right, like there would be an El Nino Madoka ready to form. This region in the center of the ocean should be warming up. And what are we seeing right now? It is warming up. And then the Nino 4, which is the only thing that isn't really forming right now, is also warming up very much. And Nino 4 somewhere in here, not really over there. Exactly, as you could see, Nino, that little location where it's cooler than average, where it's boxed on this image right here, that would be corresponding to somewhere here in this image, or in this little graphic. So it doesn't really show up. But again, the central, basically what I want you to get from this is these all correspond to the central waters of the Pacific Ocean, and they are all warming up. And during an El Nino Madoka, we need that, and we need cooling off by the water or by the coast. We need cooling off of the water by the Peruvian coast, and what are we seeing right now? Cooling off. So an El Nino Madoka may be happening, and you may be wondering, well, what on earth does an El Nino Madoka do? What does it mean for us? What are the differences between an El Nino and an El Nino? What are the differences between an El Nino pattern and an El Nino Madoka? So again, an El Nino looks something like this. And while there is no El Nino Madoka actual pattern, because again, the Madoka is just so varied, there's so many other factors like the PDO, QBO, NAO, EPDO, there's just so many different things that could play into this, that there is no real El Nino Madoka defined pattern, but there are some things we could look at. So we could look at the anomalies, and these are the typical U.S. rainfall anomalies during a Central Pacific El Nino, which is this, which is an El Nino Madoka. And you can see wetter than normal across the south, northeast, parts of the Midwest, and then a little bit drier in Ohio Valley. But mainly, the main thing I want to take away from this is drier across the west and wetter to slightly wetter across the eastern half of the nation. And in terms of temperatures, if we were to look at temperatures, you could see this is what an El Nino Madoka does to the fall in terms of temperatures. October to December, I actually made these graphics. I included the years. All of these years are El Nino Madoka years that were during the fall months. And you can see typically warmer than average across much of the northern part of the states. But there is some signs that southeast and northeast are cooling off along with the south. And then the El Nino Madoka really turns its tables during November to March, which is the winter, and how it affects the winters. You can see an El Nino Madoka affects the winter by very significant, not significant, but very significant area real estate below average, and not necessarily significant in terms of the departures, but the area that is slightly below average is fairly large. So you can see the El Nino Madoka does bring quite a bit of cooler conditions to the southeastern and eastern and parts of the Midwestern part of the country, as compared to a El Nino, just an El Nino where it's completely different. So that's just a difference between an El Nino Madoka and an El Nino. You can see that there are already big differences, even though they have the first two words of the name are the same, the El Nino part. And we keep going down into this graphic. We see a bunch of departures. This basically shows you global SST, which again stands for Global Sea Surface Temperature Departures in Celsius during the last 4 weeks. You can see equatorial sea surface temperatures are above average in parts of the central and western Pacific, which is this part, and SST are below near Indonesia. I don't know why they included that, but they are below by the Peruvian coast as well, as we saw by these regions, Nino 1 and Nino 2. So that is that. You can see this is during the last change in weekly. So it's just like these different little graphs. They're very cool. You really need to take this out and check this out. And you can see it's out of 32 slides right there, which I was showing. So it's a fairly long thing. And I don't want to go through all of this, but one part I do want to look at, which is very interesting. These are all very, if you're even more interested into meteorology, all these things, they're just great. And I won't be explaining that because that's most things people don't want to know. They just want to know how will it impact mine. So this is another thing that, if you're new to this El Nino, La Nina, ENSO thing, you can see that an El Nino is characterized by a positive ONI greater than or equal to plus or positive 0.5 Celsius. So typically needs to be at least that much to be an El Nino. The waters need to be at least that much warmer. And a La Nina characterized by negative ONI less than or equal to negative 0.5 Celsius. So you can see La Nina is usually cooler waters by the coast, and then a El Nino is characterized something like this by warmer waters by the coast. So I want to show you this graph now. ENC, this is basically what I showed you at the beginning with the summary. So it's, with 60% during the fall, which isn't really occurring yet, but it could be. So NOAA may be a little bit overhyping this, maybe a little bit overconfident in the fact that an El Nino may be developing, but I do think that an El Nino of some sort will be happening, and you can see 70% chance of that during October, November, December, January, 60 to 70%, topping out at 70%. And now we look at, this is what's also very interesting, we look at the sea surface temperature model outlooks, which basically there's a bunch of models, what they think, how warm they think above or below average the sea surface temperatures will be. And you can see the majority of the models predict El Nino to develop, but we also need to look at the fact that this El Nino that will develop won't be strong at all. This statistical average, which is in green, shows it not even passing the 1 degree above normal Celsius mark. So most of this will be this will be considered a weak El Nino if it does form. And if an El Nino does form, not an El Nino Madoka, there are some differences between that, though they do end up producing fairly similar patterns. You can see that an weak El Nino does something like this: warmer and drier than normal across the west, which we saw very similar to the El Nino Madoka pattern right here. And also fewer tornadoes, which we don't really necessarily worry about during the winter months, but above normal rainfall and storm track across the eastern portion of the country. Again, another picture that shows this very well is something like this. You can see the cold dips down into parts of the Midwest and East, and a very stormy, wet track across the eastern part of the United States, which would, with the cold combined, which we saw in this image, if I could zoom out of this, which we saw in this image right here, would produce a lot of blizzards, snowstorms, nor'easters, clippers, just in general a very snowy winter. So a weak to moderate El Nino, whether it's a weak to moderate El Nino or a Madoka El Nino, which those two at this point are 90% either one of those two happen, will produce a fairly interesting winter across the east, around an average to slightly above average in terms of snowfall, and a little bit below average in terms of temperatures for the Midwest and central part of the country. And then it could also produce warmer conditions across the warmer and drier conditions across the northwest and west, but then with an El Nino, weak El Nino, this is where the difference comes in between a weak El Nino and a Madoka El Nino. A weak El Nino, you can see, could have some wetter conditions across the southwest, very western, southwestern portion of the United States, while an El Nino Madoka, if we go to the pattern, you can see has it much drier than normal, which is nothing like this right here where it's wetter than normal. So that is basically, I just wanted to give you an update on the El Nino, what we can expect, what we can predict with the ENSO outlook, and see what's going to happen in the next couple of weeks and months. And I'm very excited for this winter. I'm very excited about this YouTube channel. Thank you guys for subscribing and supporting my channel. It has been a pleasure bringing you guys this video, and I'll catch you all guys in the next episode.